righty. So if you're familiar with additive manufacturing, you're probably thinking the plastic printers or the laser powder beds that make all of the very cool trinkets like chess pieces with a staircase inside of it, a lot of very cool things. We do not do any of that. We make very large industrial military production style parts. Artificial hips and shoulders, knees, those things are made on powder beds, and they're amazing. It's a great technology, but I always like to say if any of our material ends up in your body for any reason, it was probably a catastrophe and you most likely didn't survive. So we make giant things. And the foundation of our technology is electron beam welding, of which we've been producing electron beam welders since the very early 50s. Were kind of pioneers and widely considered one of the gold standards of electron beam welding. The way it works is they have an electron beam gun. It comes down and creates a melt pool. And then about 30 years ago, we added a wire feed to it, and we started what was a very primitive form of additive manufacturing. Not unlike if you had a MIG welder and you just kind of globbed it on and then drilled and tapped it. But we used to just call it repair, and it didn't get the cool name of additive manufacturing until years later. But this is it. We have a substrate here, and then we create this melt pool and we begin to build layers. And that's it sort of in a nutshell. We have it in a very large vacuum chamber. As you can see, this is not an adorable little powder bed additive manufacturing machine. This is an enormous machine. This machine here is our small model, which is 110 inches across by 110 inches high by 110 inches deep. So these are giant vacuum chambers. The reason why we have vacuum chambers is very important because as the metal is fully liquid, it removes a lot of the porosity that you would get with your other traditional metal additive manufacturing methods. So we can print, I know metallurgists will roll their eyes and say that there's porosity in everything if you get down small enough, but we have porosity at a level that you would see with ingots and forgings and things like that. So it's fully liquid in a very large vacuum chamber. And then now here you're seeing some of the different angles that we can do depositions and welding. Oh, also, every one of our machines is also an electron beam welder. So they tend to last a very long time. We can weld everything from, this is like a stainless steel foil, and that's 5 inches of stainless steel. So here you can see the penetration on it. So what we get with our welding process is a very deep penetration with a very small heat affected zone that reduces warping and things like that. These are examples of some of our welding capabilities and the things that we've done, the way that it works. Now, this is an additively manufactured part that would traditionally be a forging where you would have to buy, on a part this size, a couple of $100,000 worth of tooling, and it would take forever to make. Then you'd have to have a press and all the other things. This is just a piece of plate that we get here in the States. A lot of our government and military has to source from Russia to buy parts to shoot down Russian missiles, which no one thought was a bad idea. But this comes from Pittsburgh and the wire comes from Ohio. So this part here is about 4 feet long and the deposition took about 2 hours. Our deposition rate's about 25 pounds an hour. You can see where we built that up. And then here you can see where half of it was finished and then where the plate was cut away. The plate is left in to help with the machining process, and then it's consumed in the part. And then this is a little better view of it here. But just to scroll through in the last 60 seconds, this was a part we did for General Dynamics that had 10 separate pieces that they couldn't get the time or the tooling for in time for their part. So we printed it all at the same time, and we even printed a ballistic plate at the same time. So, and this is what it looked like. So this is what it would look like traditionally manufactured. And because ours was manufactured in one piece, it came out more than twice as strong. And then these are just more examples of some of the things that we've made. These are some of the exotics: tantalum, tungsten, molybdenum, niobium, the flap spar for the F-35. These are some of the different geometries and shapes we can make. These are things for scale. These are enormous parts for aerospace, unmanned submersibles, hypothetically rocket nozzles, all sorts of forgings, replacement parts for large equipment. Lockheed Martin has our equipment, and then we make very large things. And